Alright, as we get started today, I want to start with a couple of word problems. And tell you what, if I could have Brandon read the first word problem for us.
If 25 is added to the square root of a certain number, this number is equal to the square root of 13. What is the number?
How many unknowns do we have, Brandon?
One.
Just one. And so we should represent the unknown.
X.
X, but the entire word problem we just have to translate into an
Algebraic
equation, right? Using algebraic representation. So what's my equation?
25 plus x squared equals 13 squared.
There we go. How many think of the same thing Brandon said? And to solve, Brandon, we should... Okay.
Subtract 25.
Okay.
And then divide by the square root. Or take the square root.
Okay, of what?
X. And those sides.
Well, what's on the other side?
Oh, I don't know.
Oh, you don't need a calculator. You know 13 squared, class? 169. Yeah, of course we do. And subtract 25. We can do that in our head too. We're smart.
144.
See, I told you. And so what do we get for our number?
X equals positive negative 12.
Good. Positive or negative 12. It's one of those two. It's a number. It's not both. It's either one or the other. Both answers could answer the problem. So remember, with quadratics, you'll generally have two possibilities. Of course, sometimes we'll rule a possibility out, but generally two possibilities. Remember doing these from yesterday. Questions on that first word problem. Read the second one for us, if you would, Audrey.
The value of a fraction is 2/3, and its numerator is greater than half its denominator. Find a fraction.
All right, well, how many unknowns here, Audrey?
2.
And they are?
Numerator and denominator.
Numerator and denominator. And which one gets to be x?
Denominator.
Denominator, because the numerator is defined in terms of the denominator. How would we represent the numerator?
1/2 x plus 2.
Good, a half x, or x over 2 plus 3. 3 greater than half. Now here's the question, Audrey. We're going to see if you're as good as Brandon. If I'm thinking of a fraction, and I know the numerator is x over 2 plus 3, and the denominator is x, what's the fraction?
2 plus 3 over x.
Yeah. And what do I know about my fraction, Audrey?
Its value is 2/3.
Its value is 2/3. So to make an equation, I just say
Equals 2/3.
equals 2/3. And now, class, I have a proportion, which I can cross multiply. Obviously, the means here multiply very easily, Abby.
2x.
2x. The extremes are a little bit more annoying, but still not too bad.
3x over 2 plus 9.
And still have a fraction. So if I wanted to get rid of the fraction now, Maddie, I could multiply. And what do I get when I multiply everything by the LCD of 2?
3x.
And now it's pretty straightforward. I just need to move over the... There we go. Move over the 3x is a negative to get x equals 18. So clearly, class, of my fraction, we know that the denominator must be 18. The numerator is 3 more than half of that. What would be 3 more than half of this, class?
12.
12. So I'm thinking of a fraction. The numerator is 12. The denominator is 18. Abby, what is the fraction?
12 over 18.
12 over 18. And if I wanted to check, I could say, does that equal 2/3, class? Yes, then that is my fraction. It checks out. Questions on that word problem? Let's take a look at another, and we'll have Michael read this one for us.
The numerator of a certain fraction is 8 less than the denominator. If each term of the fraction is decreased by 5, the resulting fraction equals 1/3. Find the fraction.
All right, how many unknowns do we have, Michael?
2.
2, and they are?
Numerator and denominator.
Numerator and denominator. It says find the fraction, but that means there's two things to find, the top and the bottom of the fraction. Of course, you already know what the fraction bar looks like. Who gets to be x?
denominator.
Denominator. And how would I represent the numerator?
8x minus 2. 8. X minus 8.
X minus 8. There we go. Stumbled out the gate. There we go. X negative 8. So, Michael, I'm thinking of a fraction.
X negative 8. You don't even have to say it. I know what you're thinking.
What am I thinking?
Negative 8 over x.
He's a superior mind reader. He already knows the fractions x negative 8 over x. I don't even have to remind him what the numerator and denominator are. I'm betting most of you as well, just not to show off that Michael is. But hey, I appreciate Michael showing off. It brings energy to the class. Now, Michael, what does it tell me is true about my fraction?
If each term is decreased by 5, the resulting fraction equals 1/3.
Yeah, it doesn't say this thing equals a third. He says if I do something to it, I can make it equal a third. And he said I have to do what to make it equal 1/3?
Subtract 5
From
both sides.
From
the fraction.
Each term of the fraction. What do you think it means, each term of the fraction?
X minus 8 minus 5 and then x minus 5.
Yeah, the numerator and denominator are the two parts, or we could think of maybe the two terms of the fraction. I'm not thinking in terms of algebraic terms, but the numerator, decrease that by 5. The denominator, decrease that by 5. And if I do that, it will equal 1/3. So this fraction, x minus 8 over x, does not equal a third. We all clear on that? It's going to equal a third when I take 5 from the top and the bottom. So we could simplify a little bit here, Michael. Instead of x minus 8 minus 5, just make it say
X minus 12.
13. There we go. And once again, class, we have a proportion. Let's cross multiply, Kendall.
X minus 5
Product of the means.
equals 3x. 39.
Negative 39. Product of the extremes. Of course, we'll send the x over, class, as a to get, and we'll send the 39 over as a to get, and we'll end up getting x is equal to, class, 17. So apparently, my fraction has a denominator of 17. What's the numerator?
9.
So what's my fraction, class?
9.
9/17. And again, some students be like, but that doesn't equal a third. I know it doesn't. It never said the fraction would equal a third. It said if I decreased 5 from top and bottom. Well, what would this be if I took 5 away?
4.
And if I took 5 away from this?
12.
Would 4/12 equal a third? Then it checks. But this is my fraction, 9/17. Questions on that one? Okay, so a little bit of a step up from what we've been doing. Let's take a look at one more, and then we'll be done with word, or two more, I guess. One slide, 2 problems. Read this next one for us, if you would, Kendall.
Value of a certain fraction is 3/5, and the denominator is 3 less than twice the numerator. Find the fraction.
All right, how many unknowns, Kendall?
2.
And they are.
Numerator and denominator.
And which one gets to be x?
Numerator.
Yep. And how do we represent the denominator?
2x minus 3.
Good, 2x minus 3, 3 less than twice the numerator. So literally my fraction is,
X over 2x minus 3.
there we go. What does it tell me about my fraction?
The value of a certain fraction is 3/5.
So I don't have to do anything to the fraction? No. This time, just as it is, it's just equal to 3/5. So we go ahead and cross multiply, Genesis.
5x equals 6x minus 9.
And let's move over the
5x
to get,
1x
and move over the,
9.
well, negative 9 to get
9.
9. And so there we go, x is 9. So apparently 9 is my numerator. What's the denominator? Well, I was asking Genesis, but yeah, 15. So Genesis, if the numerator is 9, the denominator is 15, what's the fraction? 9/15. And there's my answer. Does that equal 3/5? Yeah, but there's my answer, 9/15. Go to read the last word problem for us, if you would. Abby.
The sum of the squares of 2 consecutive integers is 113. What are the numbers?
All right, consecutive numbers. Now, it didn't say consecutive even numbers. Had it said consecutive even numbers, class, my first number would be
X plus 2x.
2x, okay, and then the next number would have been
2x.
2x plus 2, and then 2x plus 4, and so on and so forth, right? Had it said consecutive odd integers, my first number would have been 2x plus 1, then 2x plus 3, 2x plus 5. But it didn't, it just said 2 consecutive integers. So my first integer, Abby, should just be x. First number, x. What about the next consecutive integer, Abby?
X plus 1.
X plus 1, and that's all I need. I only need 2 of them, right? X and x plus 1. And it says that the sum of the squares is 113. How would I represent that?
X squared plus x plus 1 squared equals 113.
There we go. The sum of the squares of these 2 consecutive integers is 113. How many thinking the same thing Abby said? Any questions on that? All right, what do we got to do to solve now, Audrey?
Square the first, square the last, multiply and double.
There we go. Square the first, square the last, multiply and double to get.
X squared plus 2x plus 1.
There we go. And of course, we can do a little bit of combining here to get
2x squared.
plus the 2x plus the 1 equals 113. And oh, wait a second. This is what kind of equation, class? Quadratic equation because of the x squared. In fact, since there's an x to the first class, it's called more specifically a complete quadratic. And to solve complete quadratic equations, we said we want to set the equation equal to 0. So, Audrey, continue.
You move the negative 1 over. I mean the positive 113 over.
As a negative 113 to get
2x squared plus 2x negative
112 is equal to 0. And I said yesterday that there's something we may be able to do from time to time just to make our work a little bit easier. What could I do here, anyone? Because that big number, 112. Divide everything by 2, right? Even the 0 gets divided by 2. Everything gets, just as I can multiply everything by the LCD, so I can divide everything by a particular number. And in this case, 2 is going to help me. If I knock a 2 out of everything, Maddie, what do I get? There we go. And then once it's set equal to 0, and once I've made it a little simpler by knocking a 2 out, class, my next step is to, well, in general, factor, right? Backwards FOIL, in this case, good brain. And what do we get when we backwards FOIL? Yeah.
X plus x minus
Good, x and x, signs are different, positive, negative.
minus x.
9 times 6 is 56. That's 54.
7.
Well, I'm sorry?
9 times
9 times 7, well, that'd be 63. You have a calculator if you need to try something there. This is why we spent those years in elementary school learning our multiplication tables.
7. 8 and 7.
8 and 7, all right. And we want the 8 positive and the 7 negative, or the other way around?
That way.
We do want it that way. And we'll set each of these equal to 0, and we get 2 possible answers for x, Brandon.
Negative 8 and 7.
It's either a negative 8 or it's a 7. What would be the next consecutive number after 7, class? 8. So 7 and 8 could be my consecutive integers. But if my first number is a negative 8, what's the next consecutive integer after negative 8, class? Negative 7. Either way, it says the sum of the squares of these equals 113. And if you square the 8 or the negative 8, class, you get 64. And if you square the 7 or the negative 7, you get 49. And so if you add 49 and 64, of course, you get 113. So negative 8, negative 7 is one possible pair of numbers, or positive 7, positive 8 are your consecutive numbers. Questions on this? Again, do you see how quadratics will give you multiple possible answers? Questions on these? All right, classwork on the board. Let's go ahead and practice some more with complete and incomplete quadratic equations. Of course, an incomplete quadratic equation, class, the key is to isolate the x squared, and then, of course, After you isolate the x squared, it's an x squared. So what do we think we should do?
Square root.
Take the square root, thank you. And then if it's a complete quadratic, we just reviewed it a moment ago, class, we want to set it equal to and factor. On the first one, what kind of quadratic do we have? Complete. And what's the key to the complete quadratic? Set it equal to 0. So what do I have to do after I cancel those 15s?
Subtract the 6x.
Yeah, move that 6x over as a negative, and then factor. But it's not going to be backwards FOIL this time. What should I do to factor? Common factor. Yeah, there's a 2x. Pull out a 2x, I think I heard. And then remember, set both factors equal to 0. And what should we get for our answers on the first one?
X equals 0 and 3.
X equals 0 and x equals 3. How many had those answers on the first one? All right, continue working if you're good. Questions on the first one? All right, continue working. This next to it, or this one next to it here, this next one, it's also a complete quadratic. So again, we need to set it equal to 0. Which side should be the 0, the left or the right? I would make the left your 0 because the squared variable is negative. We can't have a negative squared variable. I'd shift everything to the right-hand side. What would the equation become then? Genesis?
Positive r squared plus 4 3r.
Well, I'm taking this 4r and I'm putting it over here as a negative 4r, right?
Negative 1 or negative
Negative 1r.
and then negative 30.
And then the negative 30. And then from there, this time we would backwards FOIL continue working. Abby's finished. How many got those answers for the second one? Positive 6, negative 5? Questions? Continue. Brandon's finished. Maddie's finished. Brandon, what's the first step on this third one here?
Just FOIL.
I could FOIL. I'm lazy. I'd rather do something easier. But I mean, FOIL works. Class?
Square the first, square the last, put a minus.
Yeah, we got a pair of conjugates here, right? Sum and difference. Square the first, square the last, put a minus sign. But if you FOILed, you get the same thing, Brandon.
X squared minus 16.
Yeah, just give it the next squared minus 16 all equal to 9. What kind of quadratic do we have this time, class? Incomplete. An incomplete quadratic, class? Isolate the x squared. Okay, we'll start with I. Incomplete, isolate. So when we say isolate the x squared, Maddie, that means we need to move the to get. Oh, that's pretty easy to finish. Class x equals. How many had positive negative 5 for the third one? Questions on that one? All right, keep working. Anyone need the top row left up there, or are we good for me to erase? Anyone need it up there? All right, we'll erase. Working on the bottom two. Michael,
Did we already do that one?
We did. I'm going to show you another way to do it that's easier.
Okay.
It's a coming. Yeah, you're not doing this yet. I mean, yes, you could if you really wanted to. No, I'm not doing that. All right, Audrey's finished. Michael's finished. Let me come to Audrey. What do we do here? It's incomplete.
Multiply by 5.
I could, or I could multiply by 5 halves. I can multiply by the reciprocal and take care of both numbers at once to get x squared equals 25. And once again, Audrey, x equals. Do we always get whole number answers, class? It sure is nice when we do, though, isn't it? All right. And then actually we'll leave that up there for a second. Then on the last one here, Genesis. What kind of quadratic do we have here? Incomplete. Again, the key to solving incomplete quadratics, class, is to isolate the x squared. But there's two different x squares here, Genesis. Candle. Get rid of the small one, yeah. And I like the term little, but anyway. But to get rid of the little one, get rid of the small one. And so what do we do?
Add 4x squared.
Yeah, add the 4x squared over here to get
6x.
6x squared. Of course, if we're going to send the x squared over there, I would have to get rid of the negative 5 anyway. Might as well do that at the same time.
Positive 5.
Positive 5 over here to get 21. And then... No, not yet. We're still not isolated.
Divided with 6.
Good, divide away the 6. Now, can you divide 21 by 6 evenly, class? Now, what I've always said, if you can't divide, treat it like a fraction, which it is, and there's a word I use. Reduce. Yeah, reduce it down. How would I reduce 21 sixths?
3.
By 3 to get x squared equal to 7 tooths and 7 halves. And now we can take the square root. We have a little bit of a problem here because we can't leave our answer as positive negative square root of 7 halves. So it becomes positive negative square root of
14.
And the reason for that is so now we can take the root of the to get
2
so our answer
squared 14. Positive negative squared 14 over 2.
there we go, positive negative square root of 14 all over 2. How many had that answer? Or those answers, excuse me, for the last one. Questions on this? Questions on this? Now Michael's very astute, he has a good memory. And he recognized the problem that I wrote on the chalkboard as, wait, you did that one yesterday. We did. We solved it by the factoring method. And it was a pain because 112 isn't a number we factor very often. And I told you yesterday that if we have something that just doesn't factor easily, there was an alternate method we could use. And it was by essentially forcing this to become like those complete but kind of incomplete kind of problems. Make a PST over here, which would make a binomial square, then we just take the square root. The key, first of all, though, in doing this is to get the proper form. And you're looking at the poster over there. I'm not sure if I can get, I'll rewrite the problem. So I'm going to get the poster on the camera there. So next section in your notes, is to solve complete quadratics. So we're in that section solving complete quadratic equations. Roman numeral 1, I told you, was the factoring method. Roman numeral 2 now is completing the square. Method number 2 is completing the square. Let me rewrite what we've got up here so it actually stays on the screen. Poor planning on my part. Solve complete quadratic equations. Roman numeral 2, completing the square. Now this, you notice the poster says can't factor, complete the square. Well, even sometimes if you could factor, we know this factors. We already done factor today. But there will be times you literally can't factor. And in those times you can still complete the square. Step number 1 is to get the proper form. You want an isolated x squared. Notice this doesn't say ax squared, it says x squared, like as in nothing with it. There's something with the x squared right now that's no good, class. The negative. But remember I said if you've got a negative on your x squared, one thing you could do is just change all the signs. So this would become what then, Michael?
It would become a positive x squared. Negative 6x equals positive 112.
There we go. So we said we need a 1 in front of the x squared. Something I'd like you to jot down here is the b ideally would be even. I'm going to jot that down. Ideally, and you'll see why in a minute, ideally an even b term. The x coefficient ideally should be a negative. That would be wonderful if it was a negative. I mean, an even number, excuse me. Could be a negative, but even. And then we're going to leave a little bit of a gap. You don't necessarily have to draw the blank if you're lazy. Or you can put the plus blank if you want to. Equal to, and the constant that normally when it's set equal to 0 is here, the constant needs to be on the other side. So it leaves an empty spot for us. This is the beginnings of a perfect square trinomial. We have perfect square. This needs to be a perfect square, positive, even, right? We just have to figure out how to complete the perfect square trinomial, hence the term completing the square. There's a little formula for you to complete the square. It's this right here. Step number 2, complete the square and add to both sides. Go and write that down first. Complete the square and add to both sides. Now that's not on the poster because I ran out of room and I'm too lazy. But I'm going to make you write it. Complete the square and add to both sides. And write that little formula down. B over 2 squared. Or as I say, you half and square. Say that with me, class. Half and square. Again, half and square. And this is why it's great if this is an even number, because even numbers are really easy to half. Odd numbers are a pain in the neck. But this is even. Yay! Half and square. Well, what do we get if we half? 3 and square, 9. You say, oh, Mr. Dasky, half isn't 3. It's negative 3. Yeah, you're right, but we're going to square it. It don't matter because it's going to become positive anyway. So you don't even have to worry about the sign right here, because when you square, it's going to become a positive, which perfect square, positive even is necessary. But notice it says add to, well, you wrote add to both sides. You can't just arbitrarily put a plus 9 here. You got to put a plus 9 on the other side. Okay? So again, running through this, you want a 1x squared, you want your bx term, you want your constant on the other side. I'm going to half and square to fill in the gap. And what I have now is a PST. It has to be. I made it that way. I forced a PST into existence. I willed it into existence. And I'm going to will my PST, step number 3, into a binomial squared. Step 3, turn your PST into a binomial squared. Turn the PST, because we're too lazy to write perfect square trinomial, into a binomial squared. What is the binomial squared? Kendall?
X. Negative 3.
There we go. And squared. And on the other side, of course, we just need to, do what we would always do, is combine like terms, right? 112 plus 9, 121. So you can even use a calculator if you feel you had to, but hopefully you didn't need it for that. Step number 4. What we've already been doing when we've seen this before is take the square roots. And of course, the square root and the square class will cancel to leave me with just
X minus 3.
And on the other side, the square roots of 121 are positive negative 11. Step number 5, solve for x. It's usually going to be just a single step. Move over whatever's with the x. Here it's a negative 3. Move the class as a positive 3. And that gives me my 2 roots. 11 plus 3
14.
and negative 11 plus 3.
Negative 8.
And it says check. Quiz or test wouldn't hurt. I'm usually too lazy. So 14 and negative 8 are my answers. And you might recall that those were your answers when we solved it the other day. Questions on this? Let's do several of these together. Write this problem down there at your seats if you would, please. And I'll come over this side. X squared negative 4x negative 7 equals 38. X squared negative 4x negative 7 equals 38. Step number 1 is to get the correct form. We want the x squared by itself, check. We want the bx, and we really hope it's even, check. And we want an empty spot, not check. What do I got to do to get an empty spot here, class?
Add 7.
Add 7. So instead of x squared negative 4x negative 7, we're going to move that over and turn this number into a 45. Easy enough? Step number 2, we got to fill in the blank. What number goes here? Well, what 2 things do I have to do to get that number, class? Half and square. Again?
Half and square.
So we half, then square. And what we do to one side, do there. So we're going to add the 4 to the other side as well. In fact, if you wanted to, you could put a plus blank here in your instructions. Form is this, plus blank. You can put a plus blank over there if you need to remind you. Put it on both sides. We have now artificially created, class, a PST. What does it turn into? Binomial squared. What's the binomial squared going to be here, Michael?
Yeah, there's going to be x minus 2.
X minus 2. And on the other side, we just combine together to get
49.
49. And since we got x minus 2 squared, class, it stands to reason we should take the square root of both sides. And when we take the square root of x minus 2 squared, class, we get x minus 2. When we take the square root of 49, class, we get positive negative 7. Then we have to move over the negative 2 as a, to get what? 2 answers for x.
9 and negative 5.
7 plus 2, 9. Negative 7 plus 2, negative 5. And we're done. Just like that. Questions? I don't think we did this in Algebra 1. I think the year ran out just before we were able to get here. So I think this is new for all of you. Has anyone seen this before, completing the square? You're going to do this a lot senior year. Okay, so this is a very good skill to master. Although I will say, this is the one method students generally shy away from. It's not actually that hard, and it's something you're going to have to use a lot. You're going to be forced to use a lot senior year just because you can't solve problems without it. I'll write this one down. X squared negative 91 is equal to 6x. Now, theoretically, class, we could move the 6x over as a negative, and we could try to factor the 91. I don't know any factors of 91 off the top of my head, so I don't want to do it that way. And it's an even number, x, right? Which means it's going to be easy to half and square anyway. So here's kind of, when do I use this method? Well, if I've got a 1x squared already, if I've got an even, and I've got a number I don't want to try to split up, well, that's all of this here. So let's get it into that form. What do I have to do to create that form, Audrey?
Move 91 over as positive and 6x over as negative.
To get?
X squared minus 6x equals 91.
And I'm going to leave a little gap here. What goes in the gap, anyone? 9. How do we get that? We half and square. Half is 3 squared is 9. And we add that to both sides. Now, Genesis, I'm going to take my PST that I made, and I'm going to turn it into a?
Binomial squared.
Which is?
X plus, minus 3.
Quantity squared. And it's all going to equal? 100. 9 plus 1 is 10. Carry the 1. 1 plus 9 is 10. So 100. And then what do I need to do here, Maddie? To get? Minus a point. There we go. And then, Brandon? Add 3. And what do I get for my answers, Abby?
13 and negative 7.
Oh, so that's how I would have factored a 91. Apparently it's 7 times 13, but we didn't memorize that. You don't have to memorize. You don't have to know it. I will say this, and not picking on you, but you know earlier the 56 was giving you fits? You ain't got to ever factor again. You could do this. Now, if it doesn't have an even number here, it's going to be a pain. So that's why I like the factoring method still. But especially if it's a hard number to factor and you've got the even right here, yeah, this takes care of the problem. Now there are times, for instance, write this one down, x squared, positive 12x, negative 9 equals 0. If you're astute, you look at this problem, you say there is no way to split up a 9 to get you a 12, and you're right. You literally can't factor. Here you could have if you knew 8 and 14. Here you definitely could have, you know 5 and 9, right? Maybe you figure out 7 and 13. You literally can't factor this. It's impossible. It doesn't factor. In that case, you have to complete the square to solve. But it's not too bad with an even number here. Step number 1, what should I do, Kendall?
Uniform equation.
Right, by kicking out the... Remember to write this down next to step 1. Kick out the constant. Right, because this is your proper quadratic form right here. Ax squared plus bx plus c equals 0. Kick out the constant. To get x squared plus 12x, Kendall, equals 9 with a gap. Right? Or maybe a plus blank on both sides if you're concerned you might make a mistake somehow. What goes in the blank, Genesis? What are my 2 steps, class? Half and square. Again, half and square. So Genesis, what do I do?
Half and square.
Half and square to get?
Half of 6.
And then square it. There we go. You're looking at the b term and you half and square. All right, add it to both sides. Now what do I do, Maddie? Okay. All equal to? 45. Now here's how you know it would not have factored. If this is not a perfect square, there's no way to factor it. 49 is a perfect square, that tells me I could have factored. 100 is a perfect square, that tells me I could have factored. 45 is not a perfect square, I could not have factored it anyway, so it's a good thing we did this. What will I do next, Brandon? I'm going to take the square root of x plus 6 squared. Of course, that's easy.
X plus 6.
And that's the good news. Over here, I can't take the square root of 45, class, but I can reduce it. Abby? Factor it into...
2 things, but
What 2 things?
that's one.
One of them's a square.
20? No, not 25.
Genesis helper? 9 and 5. And which one of those can we take the square root of back to Abby?
9.
The 9 to get
3
times the square root of the
5.
5. It's been a little while, I guess, so a refresher here. And don't forget, class, we need what when we take the square root? Positive, negative. Now, it's really satisfying to add 2 to 7 and get 9 and 2 to negative 7 and get negative 5. It's not as satisfying to subtract a 6 from a positive 3 squared of 5 and a negative 3 squared of 5 because you can't do anything. You just leave your answer this way, right? You could get decimal values. Let's go ahead and do just this one here. Let's get some decimal approximations. But remember my strategy tip. Don't waste your time entering 3 times the square root of 5. Take the square root of 45 and subtract 6.
6.71.
When you subtracted 6, then subtract 6.
0.71.
Positive 0.71. Now take the square root of 45, but make it a negative when you get your answer, and then subtract 6 from that.
Negative 12.71.
And there's my 2 approximations. It's not pretty, but there's your answers. Okay? And this is the answer that I'd be looking for on a quiz or test, but it's good to know how to get the decimal values from it as well. Questions on how to use completing the square to get values you could not have gotten by the factoring method. All right, let's take a look at page 97. I want you to do 33 and 34. Page 97, numbers 33 and 34. Page 97, 33, and 34, they're at the bottom of the page. Kick out the constant, half and a square to fill in the blank, get a binomial squared, take the square roots, move the number over, you're done. Factoring is trial and error. This method isn't. I don't know, maybe some of you decide you like this better than factoring. Though on number 34, what are we going to have to do before we can do any of that?
Divide by 2.
You're going to have to divide the 2 out because you can't have anything. Oh, it's not showing up on the screen, but you can't have anything with your x squared, or in this case, your y squared. You've got to have a 1 leading the problem. If you finish early, go ahead and get decimals. Otherwise, don't bother. I don't think I asked for them on quizzes. It's been a year or 2 since I taught it, so maybe I do. I don't know. I should probably check. When you finish, check your answers. Do?
should be X, or did you just change it?
Is it X?
It's an
It's
N.
Y.
Or an
Oh, it's an N. Huh. I was looking so much at the numbers, I didn't even pay attention. Oh, yeah, no. It could certainly be an N, sorry. Good call. I was just seeing if you were paying attention. Good job, Genesis. I was working with Brecken yesterday, and he wrote something down wrong. He's like, I was just seeing if you were paying attention, Mr. Nadasky. Well done, Brecken. I'm proud of you. Good job. Shout out to Brecken. Let's try that. How many of those answers? Yeah, okay. All right, any questions on 33 and 34? Your first time? Let me move the lecterns. This is why we have this tiny little skinny lecterns in the other rooms, so they don't block views as badly. I'm going to get both of them right. And we just get at least one of them right. All right, any questions on the one we missed? All right, back to page 95. Let's do 23 and 26. Page 95, numbers 23 and 26. For sake of time, pencils down, look up this way. Move 37 over as a negative to get negative 29. Half, 6, square, 36. Add to both sides. Gives us b negative 6 squared equals 7. Take the square root of both sides, get b negative 6 equals positive negative square root of 7. Move the 6 over as a positive. You're done. How many got that for number 23? Number 26, you can't divide the 7 out. Ugh. But when you subtract the 8 to get 56, now you can take the 7 out of everything. Half and square to get 1. Put it on both sides. Then you get c negative 1 equals 9, take or square equals 9, take the square root, c negative 1 equals positive negative 3, add the 1, 4, and negative 2. How many have that on number 26? Questions? Homework, you need a chance to practice all three factoring methods. As you do, page 105, the review, 1 through 11. Page 105, the review, 1 through 11. On page 98, do word problems, 43 and 44. And on page 106, do numbers 23 and 24. Take a look at all of this in our lesson tomorrow, and have a wonderful rest of your day. You are dismissed.